Okay, so start off the second hour, we're going to be looking at another form of numbers. That's algebraic numbers. And we talked about these briefly in our first class last week, something like 4x, where we said there's two parts to that. There's the count, which is the 4, telling us how many, and the x, which tells us of what, which is the name. And when we work with these, they work just like any other numbers, just like 4 inches or 4 cows or 4 sevenths. We work with the count and the name according to the operations we're using. So if we have 4x plus 2x, when we add or subtract, we combine the counts. So 4 plus 2 makes 6. And what's our name going to be? X. It just stays x. Or if we subtract, we might have 9x minus 3x. We combine the counts. 9 minus 3 is 6, and it stays x. However, when we multiply 7x times 2x, we combine the counts. 7 times 2 makes 14, but then we also combine the names. X times x makes x squared. Now, a little bit different, we haven't seen anything like this yet, is when we divide. 8x divided by 2x is going to make, well, 8 divided by 2 is 4. What's x divided by x? What's anything divided by itself? 1. So that's 4, instead of 4 times x, it's 4 times 1, or just 4. So the x's divide out. Just like when we multiply, we have to multiply or combine the names. When we divide, we have to divide the names as well. Because remember, the definition of division, 8x divided by 2x equals 4, means we have to be able to do 4 times 2x equals 8x. 4 times 2 makes 8. Nothing times x makes x. I shouldn't say nothing because that implies 0, but no name times x makes x. So we have to be able to reverse it. We're going to come back to the multiplication and division a little bit more in a bit. We can already see we're going to be dealing with powers and exponents here because of the x squared when we combine variables. Let's look at addition and subtraction a little more closely. Looking at something like this is just an order of operations problem. All of these are addition and subtraction, so we're just going to go left to right. 7x plus 5x is 12x. Then what? 12x plus 3x is 15x. And finally, 15x minus 9x is 6x. Now, I get this question all the time. Why doesn't the x go away? Why doesn't the x cancel out when we subtract? Well, because if we have 15 blocks sitting here, and I take away 9 of those blocks, I have 6 blocks. I don't have 6 blanks, right? I don't have 6 no names. I still have 6 blocks. When I add or subtract, we keep the same name. What do I get when I try to add that? 7x plus 3y becomes 7x plus 3y. Because they have different names, I cannot combine them with addition or subtraction. But that doesn't mean that I can't do anything with them if there's different names. Now that one I can't do anything with. But I might have something like this. Now looking at that, I have 5a and 12b that I can't combine because they have different names. But the 5a can combine with 3a. Now we treat the symbol in front of it as its sign. It's a plus 3a, so we know that's a positive 3a. This is a positive 5a and a positive 3a make what? Positive 8a. 5 plus 3. Now I have 12b, and I treat this as a negative 7b. What's 12 plus negative 7? Or 12 minus 7, either way, is going to be what? 5b. Now I can't just write it like this as 8a and 5b. I have to have a symbol that connects them. That symbol is either going to be a plus or a minus symbol. Is the 5b positive or negative? It's positive. So I put a plus there. Positive 12 and a negative 7, from 0 at positive 12, negative 7 at positive 5, right? So it's a positive 5b, so it's a plus. If I have something like this, (8x plus 2y minus 3x minus 5y), what can I combine here? 8x and not 3, but negative 3, right? So that becomes what? 5x, good. Now I've got 2y and negative 5y are going to become negative 3y. So since that's negative, this is going to be written as just 5x minus 3y. The negative becomes the connecting operation between them. So you can see here it's really easy to slip back and forth between negatives and subtraction. Technically what I have here is 5x plus a negative 3y. But I can change it just 5x minus 3y. Just like we did with our integers, 7 minus 3 is the same as 7 plus a negative 3. We can switch back and forth. How about something like this? Is an x and an x squared the same name? Well, kind of, but can we combine them with addition and subtraction? Well, how about this? Is an inch and an inch squared the same thing? An inch is a unit of length. It's the distance from one point to another. An inch squared is a unit of area. It's 1 inch by 1 inch. Are they the same thing? No, they're not. If I had 7 inches plus 3 inches squared, I cannot add those. It stays 7 inches plus 3 inches squared. So the same thing here. 4x plus 11x squared cannot be combined. X squared is a different name from just x. So if I'm adding or subtracting, not only do I have to have the same variable, but I have to have the same power. So if I'm looking at something like this and I want to combine, what can I combine? Well, 4x squared, is anything combined with that? Negative 2x squared, which makes what? 4 and negative 2 make 2. And it stays x squared. When I add or subtract, I keep the same name. Anything I can combine with the 9x, or negative 9x, I should say. Positive 5x. Negative 9 and positive 5 make negative 4x. So I'm going to make that as minus 4x. Then I have 2 and 7 make 9. It's positive, so plus 9. Any questions so far? Okay. This here, 3x squared plus 5x plus 7, looks like 3 separate numbers, but it really isn't. It is a single number with 3 digits. You might be looking at something that looks a little weird, but that's actually just like many of our other numbers. Well, any of our other whole numbers. Remember we talked about our place values? Being ones, tens, hundreds, 1,000s, 10,000s. Well, these place values are actually exponents. This is 10 to the power of 0. Anything to the power of 0 is 1. That's the ones place. 10 to the power of 1, of course, is 10. 10 to the power of 2 is 100, the hundreds. 10 to the power of 3 is 1,000. That's the 1,000s place. 10 to the power of 4, 10,000, and so on. So we said if we had a number like 357, we could write it out as 3 hundreds plus 5 tens plus 7 ones, right? Well, instead of writing out the word hundreds, we could write out 3 10 squareds plus 5 10 to the ones, or just 10, plus 7 ones. So we just leave, we don't need to even put the 1 over there, the 10 to the 0 over there, do we? Do you see the similarities between this and this? An algebraic number is just like a whole number, only the place values are powers of x. This is the x to the 0, or the ones digit. This is the x to the 1, or the x digit. This is the x squared, or x squared digit. Those numbers, those algebraic numbers like that, will behave just like whole numbers. The biggest difference is we have to write it out in long form so that we have the place values written in it. So if I have something like 3x squared plus 5x plus 7, and I want to add to that 2x squared plus 9x plus 4, I'm going to set that up just like I would any whole number. Now I am adding down my columns. I can start from the right and work my way back to the left. It really doesn't matter with algebraic numbers, but we'll stick to what we're used to. And right away here, we're going to run into one of the big differences. The first big difference is we always have to write them out with the place values. The second one is there's no carrying. 7 plus 4 is 11. We can have more than one digit in a place value. So we don't have to worry about carrying a 1. What's 5x plus 9x? 14x, and it's positive, so we're going to put a plus in front of it. 3x squared plus 2x squared? 5x squared. That's positive, so we can there's no other numbers coming, so we can just leave it as 5x squared. And there it is, right there. So that's our second big difference, is we can have 2 digits in a place value. Our third big difference between our whole numbers and our algebraic numbers is with our whole numbers, or integers, either every digit was positive or every digit was negative. If I have negative 238, that means it's a negative 200s and a negative 3 10s and a negative 8 1s. Every digit is negative. However, in our algebraic number, I could have 7x squared and a negative 3x and a positive 9. Each digit can be positive or negative on its own, which complicates things a little bit for us. What's that?
Negative and positive?
Yeah, the negatives and positives in each of them. So we might have 5x squared minus 9x plus 2 plus 3x squared plus 7x minus 11. We're still going to set this up the same way. What's that? Oops, thank you. That's 7x. Thank you. So 5x squared minus 9x plus 2. 3x squared plus 7x minus 11. And we are still adding. 2 plus negative 11. So positive 2 plus negative 11 is negative 9. Negative 9x plus 7x. Well, negative 9 plus 7 is negative 2x. 5x squared plus 3x squared is just 8x squared. So when we add, it isn't terrible. We just got to be aware of the negatives. Where the negatives really mess us up is when we go to subtract. So let's work with something like this. We're going to set it up 5x squared minus 7x plus 2, 8x squared plus 9x minus 4, and we are subtracting right down the columns. So we got to remember we're subtracting. This is 2 minus a negative 4. 2 minus a negative 4, which becomes what? 2 plus positive 4. So that's going to be a positive 6. This one here is negative 7x minus 9. Negative 7x minus a positive 9, which is going to become negative 7 plus a negative 9. Negative 7 and negative 9 make negative 16, and that's an x. We keep the same name. 5x squared minus 8x squared. 5 minus 8 is a negative 3x squared. Now I want to pause for a second. Usually there's a question or two that comes up at this point. Anybody have questions on what I did? It's 5x squared minus, we're subtracting, so that's just 5 minus 8 is negative 3. Then we have the x squared. Oh. Yes?
No, I was saying, well, if it's subtraction, then the first one is going to be negative.
Not always, no. Because I could have, this is only negative because this 5 was smaller than the 8. If it was the other way around, it would be positive. Yep. The key is, when I do these, I don't do it right in the columns. I write it out over here so I can change it to plus the opposite. Otherwise, I get messed up with them. So be very careful with them. The negatives do cause a lot of mistakes. Okay, let's get to the more fun stuff. We looked at stuff like this before. When we multiply, we combine counts. What's 5 times 4? 20. But we also combine the names. X times x is x squared. Well, that one's kind of boring. So using what we learned in the first hour, we can look at something like this. 7x to the 5th times 3x squared. We combine the counts. What's 7 times 3? 21. Then we combine the names. X to the 5th times x to the 3rd is, or x to the 5th times x squared is x to the 7th. We add the powers. 5 plus 2 is 7. Good. How about this? 8y squared times negative 5y to the third. Well, we combine the counts. The parentheses are just separating out the negative. It's not telling us to do anything there first. Combining the counts, 8 times negative 5 is negative 40. The negative now does not affect the y at all. It's y squared times y to the third is y to the fifth. Good.
So you always add the power in?
If you're multiplying, as long as the bases are the same, there it's y and y, you add the powers. Now we can run into this. (11x to the third times 3y to the fifth). Remember, we can multiply and divide anything. So we're going to combine the counts. 11 times 3 is 33. But then we have to combine the names. X to the third times y to the fifth is just going to be x3, y5. X to the third, y to the fifth. So we're combining them, but they're still staying separate as well a little bit. Yes?
So when we're multiplying and when we add it, then we get.
Yeah. When we add, we have to have the same names. When we multiply, we don't have to have the same names. But when they do have the same variables, we add the exponents. If you look at this here, you know, x times x becoming x squared, you can think of it as being x to the 1 times x to the 1. 1 plus 1 is 2 for adding the powers. We might have, we saw up here that it's possible to have x's and y's in their names. So what if I start out with like 7x to the third y squared times 4 x to the fifth y to the third. I combine the counts. What's 7 times 4? 28. And now I'm going to do each name separately. X to the third times x to the fifth is x to the 8. 3 plus 5 makes 8. And then y to the fifth. Good. 2 plus 3 makes 5. When I see something like this, where should I start? Multiply the counts, the numbers. Negative 9 times 5 is, I heard someone say it there, negative 45. Now I go to the variables, one each at a time. X squared times x to the third is x to the fifth. 2 plus 3 is 5. I have y to the seventh, y to the second is what? Y to the ninth. Now I have a z here, but not over here. What happens to my z? It just stays a z. Perfect. So that's basically a single-digit algebraic number times another single-digit algebraic number. What happens if we have two-digit algebraic numbers, or just one two-digit algebraic number? Well, if we look at our whole numbers, we have 23 times 2. We wrote that out as 2 10s and 3 1s times 2 1s. So we did 2 1s times 3 1s is 6 1s. It's positive. 2 1s times 2 10s is 4 10s. We could have written this as 2 times 23 like that. But even when we go to do it out longhand, personally, I like to do my calculations vertically. Because remember we said multiplication and addition, you can change the order of the two numbers. I'm going to put the number with the most digits on top, like that. 23 goes on top, so it shortens my calculation. The equivalent of this for algebraic numbers might look like this. The 2x plus 7 is just a 2-digit algebraic number. It's being multiplied by 5. So when I write this out, I'm going to put the number with the most digits on top, 2x plus 7. I'm going to multiply it by 5. What's 5 times 7? 35. It's positive, so I'm going to put a plus in front of it. 5 times 2x? 10x. That is 10x plus 35. It's just like multiplying our whole numbers. Now, many of you are probably taught a shortcut called distributing. Distributing looks like this. 5 times 2x is 10x. 5 times positive 7 is positive 35. We put the plus in there, connect them. We get the same answer. This is quicker and shorter because it is a shortcut and abbreviation of this. This one makes more sense to me. We're actually doing the multiplication. Now, if you are good at the distributing, please feel free to use it. In fact, after a couple of days of doing it the long way, I'm going to start doing everything with distributing, just because it shortens things up. But this is really what's going on there. It really is a long multiplication. We're just shortening it up. So I might have 5x squared times 3x to the third minus 7x. I could write this out. Come on. There we go. 3x to the third minus 7x times my 5x squared. Notice I don't have to worry about lining up place values when I'm multiplying. 5x squared, is that times 7x? Say no. What is it really times? Negative 7x. So combining the counts, 5 times negative 7 is negative 35. Then x squared times x is x to the third. Think of that as being x to the 1, so 2 plus 1 is 3. 5x squared times 3x to the third, what's 5 times 3? 15. X squared times x to the third, x to the fifth. 2 plus 3 is 5. Any questions?
Any other shortcuts you can teach us?
Oh, there will be a few coming up. Try that one in your notes quick. Do you guys do it up the long way or do you distribute? Distribute? Okay, let's go ahead and do that then. 3x times 2x is 6x squared. 3x times negative 4, negative 12x. How many of you had 6x squared minus 12x? You did it the long way? Come to the same place. That's what matters. Now let's take a look if we had a problem like this. What would we do there? Notice there's no variables here, just numbers. We would do the multiplication first, right? 5 times 7 is 35. Then we'd subtract the 8. Get 27. We can have the same type of thing here. Might change that from an 8x to 9x, make it a little less confusing. So 8x, then parentheses 3x plus 7, and then minus 9x. First thing I have to do is I have to multiply. So whether you do it out the long way or just distribute, 8x times 3x is 24x squared. 8x times 7x is 56x. And I still have a negative 9x here. What can I combine with that? Is there anything in here that I can combine, I should ask? Anything I can combine with 24x squared? No. Anything I can combine with 56x? Yeah, negative 9x. 56 and negative 9 make a positive 47. Is it x squared now? No, it is still just x. When I add or subtract, I keep the same name. I could have something like this. Now, whenever we see parentheses, it should draw our attention there. Is there anything that we need to do inside those parentheses? No, there's not. So now we can step back out. Those parentheses are not an enclosing symbol. All they're doing is telling us that 5x squared minus 3x is a single number. It's not two separate numbers. So now as we step back in our levels of priority, there's no enclosing symbols. Now there's powers everywhere, but are any of them acting as an exponent? No, they're not asking us to do anything to a number, so we don't have to deal with those. So next we have multiplication and division. Do we have that? We sure do, right there. 2x times that set of parentheses. So I'm going to take 2x times 5x squared, which is 10x to the third. 2x times negative 3x, which is negative 6x squared. And everything else stays the same. Have a good night. So 7x to the third. This is a positive 10x to the third, so I'm going to put plus there. I have my negative 4x squared on the end. Now there's stuff here that I can combine. 7x to the third and 10x to the third can combine to make 17x to the third. Negative 6x squared and negative 4x squared combine to make negative 10x squared. Very good. Questions? Be very, very careful with the negatives. Those will screw us up. Also, most people get here and they're tempted to try to combine those. Don't. Those are different powers of x. We cannot combine them with addition or subtraction. Why? Because remember, an x cubed and an x squared are different. Just like an inch cubed and an inch squared are different. You've got to have exactly the same name. So something like this. Again, we look at each parentheses. There's nothing to do inside either one. So I have multiplication here and multiplication here. So I'm going to start on the left. 3x times 2x is 6x squared. 3x times a negative 4 is negative 12x. Now we have 7x times 8x, which is 56. It's positive, so I'm going to put a plus. 56x squared. 7x times 3, positive 21x. Now I can combine 6x squared and 56x squared make 62x squared. We keep the same name. Negative 12 and a positive 21x. Negative 12, positive 21. We're on the positive side. The difference between 12 and 21 is 9. So positive 9x. I'm going to try one in your notes quick. Try that one quick. See what you come up with. Some of you might not quite be finished yet. Let's go ahead and take a look. We start out up here. 5x times 3x, which is 15x squared. 5x times a negative 7 is negative 35x. Now here's where most people make their mistake. This is not 3x, it is negative 3x. So negative 3x times 6x is negative 18x squared. Then we have negative 3x times negative 2 is positive 6x. Good. Now we can combine 15x squared and negative 18x squared. Positive 15, negative 18 is negative 3x squared. Negative 35x and positive 6. Negative 35, positive 6 ends up at negative 29x. What do you think? Good stuff? I caught that. How about a 2-digit number times a 2-digit number? This is no different than any long multiplication we've done. 2x plus 7 times 3x minus 4. Negative 4 times 7 is negative 28. Negative 4 times 2x is negative 8x. We'll leave a blank here. We move over. 3x times 7 is positive 21x. 3x times 2x is 6x squared. Looks very much like the long multiplication we did with the place values written in, doesn't it? Negative 28 combines with nothing, so it stays negative 28. Negative 8 and positive 21 is a positive 13x and 6x squared. Now, I know a lot of you have seen this, two binomials, they call it, multiplied together. And if you have, you probably learned a little acronym called FOIL. Right? FOIL, the F stands for first. You multiply together the two first digits. 2x times 3x is 6x squared. Notice we had that. O stands for outside. Multiply the outside two digits. 2x times negative 4x, or 2x times negative 4 is negative 8x. We had that. I stands for inside. We multiply the inside two digits. 7 times 3x is 21x. We had that. The L stands for last. You multiply the last two digits. 7 times negative 4 is a negative 28. We had that. The difference is here we have to figure out that we got to combine those two. 6x squared doesn't change. Negative 8 and 21 make a positive 13x. We have the negative 28. We get the same answer. It's just this here over here looks more like our whole number multiplication. If you've done FOIL and you're good at it, please feel free to keep doing it. Now the other reason why I don't like FOIL is you can run into problems like this. FOIL doesn't work here anymore, does it? Because now we got a middle digit. It becomes flaming oil. But if I write it out, like this and multiply, it multiplies just like any other whole number. I mean, you realize you're just going to keep doing this up here. It'll work out. Last thing I want to show you is basic division. For division, we're only going to look at single-digit numbers. So something like this. 12x divided by 4. When we divide the counts. 12 divided by 4 is 3. And we also combine the names. Well, x divided by nothing is just x. But I could have 18x divided by 3x. Here I'm still dividing the counts. What's 18 divided by 3? 6. X divided by x cancels out. It divides out. Remember we talked about that earlier. Anything divided by itself is 1. So you think of that as 6 ones, which is just 6. We might have 48x to the 5th divided by 6x to the 3rd. We can divide the counts. What's 48 divided by 6? 8, right? X to the 5th divided by x to the 3rd. We haven't looked at anything like that yet. X to the 5th is 5 x's multiplied together. X to the 3rd is 3 of them. You've got it. We subtract. 5 minus 3 is 2. X times x, or x squared. Yeah, 5 minus 3 is 2, yeah. That is the shortcut. So if I have like 12x to the 13 divided by 6x to the 5th. Yeah, all I'm going to do, I'm not going to count out all the x's. 12 divided by 6 is 2. X to the 13 divided by x to the 5 is x. And we do 13 minus 5 is 8. X to the 8. That's a little more complex than we want to discuss right now. We'll come back to that later. So something like this, we can divide 32 divided by 4 is 8. Now, just like we combined, when we multiplied, we combined each variable separately. When we divide, we're going to do the same thing. X to the 5th divided by x squared is x to the 3rd. 5 minus 2 is 3. And then y to the, I think this is 1. 2 minus 1 is 1, right? So y to the 1 or just y. 8x to the 3rd times y. Okay, you asked it, so I got to show you. What if we had something like this? X to the 3rd over x to the 5th. X to the negative 2. Very good. Well, what does that really mean? Well, 1, 2, 3 x's, right? Divided by 5 x's multiplied together. I can cancel out 1, 2, 3. There's 2 of them on bottom. That's 1 over x squared. X to the negative 2 and 1 over x squared mean the same thing. When we look at powers in more detail, negative powers are really reciprocal. So x to the negative 7 is the same as 1 over x to the 7th. We'll see that more later on in the course. For now, there is a new, well, let's do this. Homework 1, which was supposed to be due today, is going to be due tomorrow. So that'll be Wednesday at 4 p.m. Again, my math lab is going to give you a nasty message that you're past due, just keep going. It might even say it's going to try to take away half your points. Don't worry about it. I'll fix that when I transfer it to Blackboard. Quiz 1 is due tomorrow, Wednesday at 11:59 p.m. On the quizzes, you don't have any of the helps like you do on the homework, but you do get 2 attempts. The catch to that is you can't just attempt individual questions. The second attempt, you have to redo the whole quiz. The system automatically takes the highest score, so unless you get a perfect score, there's no reason not to take the quiz again. If you do worse, it's still going to take the highest score. The catch is you still have to get it done within the time limit. You have to have it done by 11:59 p.m.
How many times can you take again?
The quiz, you can take it twice.
Are they timed?
The homework is not timed. The quiz, I think, is set for like 120 minutes, so 2 hours, which is the default. I think it's 122 or something like that is the default. Then there is also homework 2, which is the new material from tonight, which is due Thursday in class, so Thursday at 4 p.m. What's that? No. I would suggest you do them in this order. Homework 1 first, because quiz 1 is the same material as homework 1. And then do quiz 1, and then do homework 2 last. Those of you who had problems with your books, I guess everybody, if you have problems getting quiz done tonight, let me know and I'll extend it out till like noon tomorrow or something for you. Okay, we do have a few minutes to work if you want to. Otherwise, we'll see you on Thursday.